In this video, we are going to look at the different types of mapping and what a domain and range is for simple types of mapping. Before we do that, we have to understand what these four sets represent. The top one, which is this strange n, called a double strike n, represents the natural numbers. And the natural numbers are simply the positive integers. To show that group of numbers, or set of numbers, I've just used these curly brackets. And it indicates that I'm talking about a set. And the ellipsis on the end, it's just illustrating that these numbers continue forever. Next, we've got the double strike Z. It represents the integers. So the integers will contain the natural numbers and all of the negative numbers as well. The Q represents the rational numbers. A number is rational if it can be expressed as a fraction, and the numerator and the denominator of that fraction have to be integers. So a good example is something like 0.3. Although it's a decimal, you can easily express it as a fraction, 3/10. Lastly, and this is most common for what we're going to use throughout this chapter, is the real numbers. A number is real if you can find it on the number line. I'll show you what I mean. Okay, alright, for example, here is my real number line, and you can clearly find a heap of integers on here, so all of these numbers here are real. You can also find numbers like a half, which are rational, but because you can find them on this line, they're also real. And you can also find numbers like pi, which can't be expressed as a fraction, so they're not rational, but you can find them on the number line, hence they are real. Next, we're going to look at domain and range. The domain and range relate to types of mapping. So if you were going to talk about a domain or a range, that means there must be some sort of mapping that you're referring to. I've got three mappings written on the board down here. Each of these mappings have a domain and a range. The domain is the set of input values for each mapping. So the numbers that go in for X, and the range is the number that the mapping spits out. So when you put a number in for X and you evaluate it, whatever the result is will be your range. Cool. Right. For each of these mappings, we're going to work out the domain and the range. Okay, firstly, so we're looking at f of x. The mapping is 4x. We need the domain. That's the numbers that we're going to put into the function for x. It's given here. This is the domain, 2, 6, 7 and 10. It's a group of numbers. This is a set, by the way, and usually sets aren't written like this. They'd be written like this up here in a list, but I've written it in this strange arrangement because it will help me explain something later. So here's our domain for f of x. Now to find the range, we simply take each number and put it into the function. So 2 goes in, 6 goes to 24, 7, 28, 10, goes to 40. There we go. So there are 4 numbers in the range, and I'm going to call it f of x. Alright, next mapping. We've got g of x down here, it's x squared. What's the domain? The number's going in for x. Given. We've got 4 numbers in our domain. And usually that is the case, you will be given a domain. Okay, let's work out the range. So we take each number and we're going to put it into the mapping. Okay, -1 goes in, maps to 1. 1 goes in, it also maps to 1. So I won't write it twice. -4 goes in, goes to 16. 4 goes in, it also goes to 16. So there are only 2 numbers in the range for g of x. Finally, we've got h of x, which is plus or minus root x. A bit of a strange one. So let's start with these 3 numbers, let's start with 1, which is in our domain. In it goes, it maps to 1 and -1. 4 goes in, it maps to 2 and -2. 25, 5 and -5. Cool. Okay. And there's the range for h of x. We're now going to look at the type of mapping that each of these are. There are 3 types of mapping. One-to-one, many-to-one, and one-to-many. The word on the left represent the numbers in the domain, and the words on the right represent the range. To see what I mean, we're gonna try and figure out what type of mapping f of x is. Okay. To do that, we need to have a look at how many numbers each of these in the domain map to. Well, 2 maps to 8, 6 maps to 24, 7 to 28, 10 to 40. So 1 number in a domain maps to only 1 number in the range. This is a one-to-one function. Okay, next one, g of x squared for this domain. -1 maps to 1. 1 also maps to 1. -4 maps to 16 and 4 maps to 16. Okay. So in this second example it is slightly different to the first one because we have many values in a domain mapping to 1 value in the range. It's many to 1. Okay, and finally our last one. You're probably ahead of me. Let's see. So the first one we've got 1. It maps to 1 and -1. 4 goes to 2 and -2. And 25 goes to 5 and -5. Okay, and you've probably guessed what type of mapping this is. 1 value in the domain goes to many in the range. And it's also true for 4. 1 here goes to many in the range. It's a one-to-many mapping. Finally, of these three types of mapping, only two are regarded as functions. If a mapping is one-to-one, it is a function. If it's many-to-one, it is a function. But if it's one-to-many, it's regarded as not a function. In the next video, we're going to look at how to identify these types of mapping in a bit more detail using graphs and with slightly more complicated domains and ranges.